Hello everyone. Today we are going to learn how to find the equation of graphs perpendicular to others and passing through a specific point. Now here I'd like to explain to you what it means that the gradient of a perpendicular line, that is a perpendicular line with another line, is the reciprocal of the gradient of the first line with a different sign. For example, let's say the gradient of the first line is 2. Then the reciprocal of 2 is going to be 1/2. Now you might think, where did you find the 1? Now we can write number 2, a whole number, we can write it as a fraction by adding 1. Okay, and that's how you easily can find the reciprocal. So it's going to be 1/2. But be careful here, because the reciprocal of the second line that is perpendicular to the first line, it is going to be with a different sign. So add a minus. But what if I have -2, for example? And in the same way, -2, I can change it to a fraction, becomes -2/1. And so the reciprocal, it is going to be 1/2 with a different sign, which means positive 1/2. You see? What if I have a fraction, for example, the 3/4? And 3/4 becomes -4/3. So flip the fraction of, or the gradient, if you turn it upside down, and then change the sign. So if it's negative, becomes positive. If it's positive, it becomes negative. What if the gradient, for example, is a decimal number? What if it is 0.5, for example? Then again, you can change this to a fraction. 0.5 is the same as 1/2, right? 5/10 or 1/2. And so the reciprocal of 1/2 is going to be, I'm going to do a little line here so we don't mix the numbers with each other. So reciprocal is going to be 2/1 or simply 2. But remember, with a different sign, so we need to add a negative sign in front of it. So it's going to be -2. So from 1/2 of the first one, -2 for the gradient of the second line that is perpendicular with the first line. Right, let's have a look at an example. Now, we have this equation. This is the equation of our first line. I'm going to write it on this side. Y equals minus 1/3, actually 1/3 x minus 2. Okay, now we need to find the line, the equation of the line that is perpendicular to this first one here, perpendicular, and passes through a point 2, 9, which I'm going to label. This is the x and this is going to be the y, all right? Because I'm going to need both of them. Right, first thing first, let's get the gradient out of the first one. The gradient of the first line, let's call it m1, is -1/3, which means the gradient of our perpendicular line. It is going to be how? It is going to be, so flip this fraction upside down, is going to be 3/1 or simply 3, and change the sign from minus positive. So it's +3 or simply 3, okay? Just 3. Right, now we can substitute this into the general formula of the equation of a straight line, which is y equals mx plus c. Let's substitute this m, so it's going to be 3x plus c, right? Now, how can we find the c? We have the coordinates of the point, 2 and 1, so this is what we substitute, 2 and 9. So y is 9, 9 equals 3 times 2 plus c. So 3 times 2 is 6, 9 equals 6 plus c. Take away 6 from both sides, and then c equals 3. So we have the c, we have the m, which is 3, and the new equation of the line that is perpendicular with the first line is going to look like this. Y equals 3x plus 3. Y equals 3x plus 3. And we can check it back again. If I use the right gradient, yes, I have. There it is, 3, and the c is 3. Right, the next equation looks like this. So this is the formula of the equation of our first line. And I'm going to write it up here. 3y equals 8 minus 2x. We need to find the equation of the line that is perpendicular with the first line. So what we need to do, we need to rearrange, because all we need is y by itself on one side of the equation. And you can do this by dividing by 3 both terms. And with that, both terms, I mean both sides. And with that means every single term of every side. So we divide the 3y by 3, we divide the 8 by 3, and we divide the minus 2x by 3, right? And this is what this equation is going to look like. Y equals 8 over 3 minus 2 over 3x. Now here you have to be careful, because it is a common mistake when you think, oh, gradient is 1/3. The gradient is the number, including the sign, that is opposite, or is next to x, or multiplies the x, or is attached to the x, right? Remember, so just so that you don't forget, why don't we swap 8/3 and minus 2/3 x? So we write minus 2/3 x, okay, plus 8/3. So this is the gradient now, minus 2/3. Now, how about the gradient of our second line? Is the reciprocal, so it's going to be 3 over 2, and with a different sign, plus, from minus becomes a plus, or simply 3/2, or 1.5. You see, you can use either of them as a decimal number or a fraction, however it fits better in the equation. You will find out through the equations that you will be given. Right, but actually, to be able to find the equation, the full equation, we don't just need the gradient, we need the c as well. We need this one here. Now, if we go and look back at the question, it says both lines, can you see, they cross the y-axis at the same point. Okay, at the same point. Now, something that you have to remember here. So I'm going to draw a little line here. Right. If we, and a little line there. Now, I'm going to sketch a couple of axes, x and a y. It says they cross the y-axis at the same point. So let's say if these two are perpendicular with each other, they cross the y-axis here. Let's say these two lines are perpendicular. Can you see? I'm trying to make them as perpendicular as possible. They cross the y-axis here. Now, what do we notice? Okay, we don't know the y coordinate, the y of this line. Okay, but do we know the x? Can you see? How much is the x of this point here? Let's call it an A. How much is the x of point B? Let's call it a B. What do you think? Can you see? Oh, the x is actually 0. X is 0. And both lines go through a point that has x coordinates as a 0. So what I need to do, actually, I'm going to use the first equation to be able to find the y, right? Because I know x is 0. How about the y? Let's substitute here, right? So this is what is going to happen. Y equals minus 2/3 times x is 0. X is 0. Let me write it down here. So times 0 plus 8 over 3. So all this is 0. So y equals actually 8/3. And suddenly, we know the coordinates of the point that our second line, not only like first line, but the second line goes through. So what are the coordinates of that second point? It is going to be 0, 8/3. Okay. Right, so we know the coordinates of the point that our second line goes through. We know the gradients. Now, what do we need to find out? We need to find out the c. Let's substitute. So y is 0. No, sorry. So this is the x and this is the y. So y is 8. Let's do it straight away. 8 over 3. I'm going to change this to 8 over 3 equals 3 3/2 times 0 plus C. Obviously, this one becomes 0, so C is, C is 8/3 because 3/2 times 0, all this is 0. And C is 8/3. Right, now what time is it? It's time to substitute into the equation. So we have y equals 3/2 x plus c, which means plus 8/3. And this is our final answer. So this is the equation of a line that is perpendicular to this complicated line or this complicated equation, and both of them go through the point 0, 8/3. This one here. Right. Now, here you have some independent work. You can follow exactly the same strategy that I followed. So write the first line on the left-hand side. It helps you memorize the gradient. It's the same strategy I used for parallel lines as well. So on the left-hand side, the first line, and on the right-hand side, write the new gradient of the line that is perpendicular in this case, and work out with the points that they go through to be able to find the C, and then rewrite the whole equation again. And a little bit more work here. There you go. 4 more questions. The first one is negative gradient, which means the gradient of the second line is going to be positive and a reciprocal, so it's going to be 4/1 positive, so 4. All right. Here you need to do something before you find the gradient, because you need to make y the subject of the equation here. The same here, only y on one side of the equation by itself, no minuses, no numbers attached or loose numbers. Again, here you have to change. So you have to do a little bit of work in number 2, 3, and 4 before you go to finding the gradient of the second line. Thank you very much for watching Mathssteps. I hope you enjoyed the lesson and have a lovely, lovely day. Thank you for supporting Mathssteps. Bye-bye.